Hello everyone, I'm Sophie from Carnegie Mellon University. I'm presenting our paper, Seeking New Measures for Gender Bias Effects in Open Source Software. It is a well-known problem that the gender ratio in open source software community is highly skewed. This is a graph we recently plotted for GitHub public repositories. Among all contributors whose gender can be inferred from their names, less than 9% of them are women. Low gender diversity is problematic for several reasons. One is that it harms project success. A prior work shows that a gender-diverse team is associated with higher productivity. Low gender diversity negatively affects equity. Several studies show that a male-dominant environment is often unfriendly to women. This is especially true in open source. Low gender diversity also limits contributors' opportunities for getting a better job. Open source experience has been used for job hunting, and many employers do consider open source experience when hiring people. If women are leaving open source due to unfriendly culture, it is harming their chances of advancing their career. Our study is based on the prior work on investigating gender bias effects on GitHub. They used the framework proposed by William and Dempsey. It is a framework developed based on interviews and meta-review of the literature. It has been widely used in other contexts, but never in software engineering. The four effects described in this framework are prove it again, maternal wall, tightrope, and tug of war. Prove it again is the effect that a group doesn't align with stereotypes and needs to provide more evidence to demonstrate competence. To test this effect, they use several count-based features that compare these four measures between men and women: length of a pull request description, acceptance time, length of their bio, and PR concentration, whether people focus more on a smaller number of projects. They only found the last measure to be statistically significant. Women concentrate on fewer projects than men. Another bias effect is called the maternal wall, meaning that people have the assumption that a mother needs to choose a priority between work and family. Therefore, mothers' work and resumes are often held to a higher scrutiny, and many working mothers are subtly pushed out of their positions. To test its effect, they counted the number of profiles containing children, but they didn't find statistically significant difference between the numbers of men and women. Another effect is called the tightrope. It means that the group's behavior at the extreme ends can have negative repercussions. Here, instead of count-based features, they analyze the language used by men and women. They measure the rates of politeness, percentage of profanity, sentiment, and gender stereotypical speech. They found four of them are significant, proving the presence of the tightrope effect. Came out in the same year, another study also observed the effect of tightrope. Here they measure the sentiment in review comments by men and women. We can see that overall, men express more sentiment than women, be it positive or negative. The last gender bias effect is called tug of war. It describes the effect that in a heavily competitive environment, women sometimes discourage other women because either they doubt the competence of other women or they think encouraging others might increase the level of competition. They compare the PR acceptance rate by female PR reviewers when men are the creator versus when women are the creator. They also compare the time between the submission of the PR and the acceptance of the PR. In other words, the pushback against co-contributions from women reviewers. However, they didn't find support for this effect. However, in another study that looks at the language in the review messages, people found evidence supporting the presence of tug-of-war bias. The figure here shows the sentiment of women and men as reviewers for men and women in 6 open source projects. Let's look at the comments coming from women. The red bar is commenting on woman author, and the blue bar is commenting on a man author. We see that in most cases, women express more negative sentiment towards women than to men. We came up with an idea after reading these studies. It is possible that count-based features, such as the length of a comment, are too superficial and cannot capture the nuance of gender bias effects in open source. However, if we dig deeper and look at the language that people use, we might be able to discern the bias effects. Therefore, we propose a new idea, not yet tested. We can borrow theories from linguistics and results from computational linguistics as features to build a model. We can use this model to see what linguistic features are more likely to be associated with a higher success rate in code contribution. If certain linguistic features that are more often used by women are found to be associated with a lower successful rate, then it might suggest the presence of implicit bias. In the rest of this presentation, I will go over some of the literature that inspires and supports our idea. At the end, I will talk about our preliminary progress. We admit that we assume binary gender in this study. We know gender isn't binary. However, currently we are limited by the gender inference technology and the existing theories, most of which, if not all, assume binary gender. We do keep non-binary gender in mind and will revisit it in future works. There are many studies showing that people unconsciously adjust their language. For example, in this paper, Echoes of Power, the authors show that people coordinate more with speakers with higher power than with those who have lower power. In this plot, bars representing how much do people coordinate with other speakers. Green means before someone requests for admin, and purple means after success. After they become an admin, they coordinate less. There are also studies showing that different genders do talk in different ways. For example, this study examines tweets and found that certain linguistic features are used by one gender more often than the other. There is of course a risk of gender stereotyping. They clustered these tweets and did find that many clusters have stronger gender orientations. Some of the clusters show conflicts with prior studies. Closed vocabulary is a commonly used technique in linguistic studies. Linguistic inquiry and word count, LIWC, is a commonly used vocabulary among social sciences, such as psychology. It divides words into linguistic categories and analyzes a text by counting the percentage of each category. In a study that examined 1,400 text samples, the authors found that some categories are more often seen in one gender than another. For example, men use more words per sentence, and women use more positive feelings. Another closed vocabulary is the politeness strategies. It is based on the politeness theory. The politeness theory discusses two types of politeness, defending a person's two types of faces. A negative face is the want of every competent adult member that his actions be unimpeded by others. Therefore, negative politeness includes indirect requests such as, "Could you do something?" instead of a direct command. A positive face is the want of every member that his wants be desirable to at least some others. Therefore, positive politeness includes praises or gratitudes. Based on the politeness theory, a prior work compiled a list of strategies for measuring politeness of a text. In addition to text, there are also studies on emojis, which are also used to express one's ideas. A study shows that women are more likely to use emojis. However, many of these studies may not apply well to our context. One big reason is that these studies use corpora with larger vocabulary. For example, topics discussed on Twitter must be wider than those on GitHub. Many vocabularies may be rare in the context of software engineering, and most of the top emojis found in prior work can rarely appear in a code review conversation. On the other hand, open source conversations have many domain-specific lexicons. Therefore, our current first step is to code several pull requests manually to identify relevant vocabulary and language unique to the open source context. This table contains part of our preliminary findings. We found these features appear often in GitHub code review conversations, and we grouped them based on their prior literature. It is not yet clear if such gender association is present in open source. We also observed some variations that might be difficult to measure, such as the different levels of formality. Some people talk as in an email, whereas some other people might be more casual. There are also many domain-specific lexicons. For example, we found nitpick to be an interesting case. Many reviewers will put nit before they point out some problems. We understand it as a negative politeness strategy. They avoid putting burdens on the authors to make such changes, to save authors negative face. In summary, we started from a pilot work that tried to investigate the gender bias effects in open source. We proposed a new framework for detecting gender bias using linguistic features. We reviewed linguistic literature and examined them on pull request conversations. Along the way, we observed some linguistic features unique to open source.